Hello, welcome. In this video, we will design a class to represent graphs. So we're going to have this graph class to represent a graph. So internally, we have all the vertices in this list, and we have this neighbor is a list of adjacency edge lists. And this is the constructor. We construct the graph from this vertex list, and this is the edge list. And this is the get adjacency edge adjacency lists, and this is the get size, the number of vertices in the graph. And this is get vertices and returns the vertices in the graph. And the return is a list of the vertices. And this is get one vertex and using the index. And this is to get the index and given the vertex. And this is to get all the neighbors for the vertex with the specified index. And this is the get degree, returns the degree for a specified vertex. This is the to print all the edges in the graph. And to clear, to remove all the vertices and edges from the graph. Add one vertex into the graph. Add one edge between the vertex U and V from U to V. This is performing the traverse and using the depth first search to traverse all the vertices in the graph. And this is the breadth first search to traverse the graph using the breadth first approach. We're going to introduce all this later in this chapter and introduce the depth first search and a breadth first search. Now, suppose we have this graph. We're going to write a test program to use it. So here's a test program. So here's from graph, we're going to import graph. We have the graph. And now let's use the map. We have the US map and the figure in the book. And that's the Seattle, San Francisco, Los Angeles, Denver, and all the way in Houston. And this 11 cities. And this is the edge list. We're going to use that as input. It's convenient. We have 0, 1, so it means from Seattle to San Francisco. And 0, 3 is this edge from Seattle to Denver. And so likewise, we have 3, 0. So 3, 0 from Denver to Seattle. So this is symmetric. So we're going to create a graph. So let's create a graph now. So this is the constructor and graph, and with this all this vertices and the edge. So we have it, and invoke the methods here. It's this is the graph one dot get vertices, and this and here the number of vertices in the graph, and we're going to get this is graph one dot get size, and this is the graph one dot get vertex, and here is and graph one dot get index. So get index at Miami here, and this is to get the degree. So we're going to print all this and right here. So here's another graph. So we use this. The vertices and the edge and create a graph. Now, let's look at the implementation of the graph class. We're going to store the vertices here initially. So here you can have a default when you create the graph, if you don't specify any of this vertices and edges, so by default, this is empty, that's 0. And we're gonna have this vertices now, and here is all the neighbors. We're gonna get adjacency lists. So this is to get adjacency lists from the edge list. So get and all the edges and put it in the neighbors bracket 0 for this edge UV added. And this is get size and get vertices and get a vertex given the index and get the index given the vertex and get neighbors and get degree and print the edges and clear everything and add a vertex. So add a vertex, and so the edges, we have not added anything, so this is empty, and add an edge, so this is add an edge. So this is perform the depth first search and perform the breadth first search. We're going to talk about this depth first search and breadth first search in the following sections. That is all for this section on modeling graphs. See you in the next section.